What if the secret to making our favorite treats healthier wasn't about taking stuff out, but about redesigning one of the most important ingredients from the ground up? Today, we're diving into the science of engineering the perfect fat. Seriously? Just imagine for a second biting into a perfectly soft, fluffy piece of bread or a decadent cake, but with zero guilt, knowing it was made without all the unhealthy fats we're always told to avoid. Well, that dream is exactly what food scientists are working to make a reality. Now, that delicious, guilt-free future sounds amazing, right? But it all hinges on solving a really fundamental problem in the world of baking, what I'm calling the great fat dilemma. Okay, let's break this down. On the one hand, you've got your traditional solid fats like butter and shortening. They are absolutely fantastic for texture, for taste, for that wonderful mouthfeel we all love in baked goods. But, and it's a big but, they're often packed with unhealthy saturated fats. Then, on the other hand, you have heart-healthy liquid oils, like canola oil. The problem is kind of right there in the name. They're liquid. They just can't give a cake or bread the structure it needs to be light and fluffy. So the question is, how in the world do you get the amazing texture of a solid fat with the health benefits of a liquid oil? Well, it turns out the answer isn't to change the oil itself, but to change its physical form. Scientists have come up with a really clever solution. They're literally turning healthy liquid oils into functional solid-like gels. And it's called an oleogel. The easiest way to think about it is like a microscopic sponge. You take a food-grade gelling agent, in this case candelilla wax, and it forms this intricate, three-dimensional crystal network. That network then traps the healthy liquid canola oil inside. It's a brilliant way to transform a liquid into a semi-solid fat that behaves just like shortening, but keeps the awesome nutritional profile of the healthy oil. But of course, there's a catch. On their own, these initial wax crystals are a bit chaotic. They can form structures that are too big, kind of brittle, and just not strong enough. That doesn't give you the perfect texture we're aiming for. So this basic solution needed a little extra help. And this is where the real engineering comes in. We're talking about refining that basic gel molecule by molecule to create the absolute perfect fat substitute. So researchers introduced a kind of secret ingredient, ethyl cellulose, or EC for short. It acts as something called a crystal habit modifier. Now just think of it as a personal trainer for those wax crystals. It doesn't change what the crystals are made of, but it gets in there and organizes them, pushing them to grow into a much stronger, more uniform, and tightly packed network. Okay, so how much of this crystal trainer do you actually need? Well, the researchers ran a bunch of tests with different amounts, and they found there was a perfect Goldilocks zone. As you can see from their results, too little didn't do much, and too much actually started to mess up the structure. But that sweet spot, sample ST10.0, was right at a 5% concentration. That was the one. And the proof was, well, crystal clear. Under a microscope, the ST10.0 sample showed this dense, beautifully organized crystal network. It also had the most intense birefringence, and I know that's a mouthful, but it basically just means the crystals were incredibly well organized, kind of like a perfectly stacked brick wall instead of a jumbled pile of rocks. This superior structure was so orderly that it even changed how the gel interacted with light, giving it the highest yellowness index, which is another key sign of a really strong, well-formed gel. Then an X-ray analysis zoomed in even further, giving us this number, 4.002 angstroms. Now, this tiny measurement is called D-spacing, and it tells us exactly how tightly the molecules are packed together. For the perfect fat, you want that number to be as small as possible. And guess what? ST10.0 had the lowest D-spacing of them all, proving it had the most compact, most rigid structure, exactly what you need to mimic a traditional solid fat. All right, so the science totally checks out. We have an optimized, healthy fat substitute that looks perfect on paper. But does it actually work in a real recipe? It's time for the ultimate test, making steamed bread. The researchers basically set up a bake-off. There were 3 competitors. First, you had bread made with just regular liquid canola oil. That's our control. Second, a batch made with that basic oleogel, the one without our crystal trainer. And finally, the challenger, bread made with our new optimized ST10.0 oleogel. And the results were pretty incredible. The bread made with the optimized gel, SB2, was the undisputed champion. It was significantly wider and taller than both of the others. This showed that its superior internal structure allowed the dough to rise higher and hold its shape way better. But the real victory was what you saw on the inside. When they looked at the crumb, the optimized bread had this amazing, fine, uniform network of tiny, round pores. What that means is the oleogel helped the dough trap all those little gas bubbles perfectly during fermentation. And that leads to better aeration and ultimately a much softer, more appealing texture in the final product. There was another really surprising benefit too. The optimized bread actually browns less. Now, you might be thinking, wait, isn't browning a good thing? Well, in this case, less browning can actually mean a reduction in some potentially harmful compounds that form during the Maillard reaction. That's the complex chemistry that gives browned food its flavor, but it can also create some unwanted byproducts along the way. So, what does this all mean when you put it together? Well, it points toward the very real possibility of baking a healthier future for all of us, not by accident, but by intentional design. And that right there is the key takeaway. As the researchers put it, this isn't just about fiddling with a recipe. This is functional food engineering. It's about intentionally designing the very building blocks of our food, from the molecular level up, to have specific beneficial properties for a specific job. And this amazing technology isn't just for steamed bread. I mean, imagine healthier, clean label versions of cakes, cookies, pastries, even things like spreads. And yes, frankfurters. All of them using healthier oils, but with that fantastic texture we get from traditional solid fats. The potential is just enormous. So it really leaves us with a fascinating question for the future of food. As we get smarter and better at engineering the very things we eat, could science finally remove the guilt from our guilty pleasures? It's definitely something to chew on. Thanks for joining me.